Welcome to Lesson 3, Unit 7. Today we're going to be talking about special right triangles, which is going to be a different brand of right triangles. There are going to be some rules that we're going to learn that are always going to apply to these kinds of right triangles. So that's what we're going to be talking about today. Now if we look at the notes, it says, remember that a square has 4 congruent sides and 4 right angles. You guys all know that. Now what happens if you take a square and you cut it in half diagonally? Okay, so obviously it's showing you if you do that, then you have 2 triangles. Okay. Now, what does that do to the sides and angles of the newly formed triangle? Okay. So in each triangle, so it splits it into 2 triangles, but in each triangle, some things are going to be true. If you look, one thing that we have is a 90-degree angle. So we got one 90-degree angle. Okay. We also have 2 congruent sides. That's easy to see. Now the last thing that might not be so easy to see, but it definitely makes sense, is if we once had 4 right angles. Okay. I'm actually going the 2 that got cut in half, I'm gonna do a different color for those. Let's do blue. They got cut evenly in half. So that means for each triangle, the other 2 angles are going to be 45 degrees. So we also have 2 45-degree angles. So that's what happens when you cut a square in half diagonally. Okay. Now we have an example question. So if we had a square, okay, and each side was 6 centimeters, because that's what a square is, all the sides are the same, and we cut it in half diagonally, it's asking us to solve for the hypotenuse. Now, obviously we know how to do that. We're going to use Pythagorean theorem, okay, and we know A and B, our legs are both 6, so we have 6 squared plus 6 squared equals c squared, which is going to be 36 plus 36. 72 is equal to c squared. Now, of course, you're going to want to take the square root to cancel out the exponent of 2. So c is going to be equal to the square root of 72. Okay. Now, what we also learn is that if we have, most of the time on SOLs and tests, they ask us to simplify the radical. So if we simplify the square root of 72, it's actually going to be 6 root 2 is equal to c. So the square root of 72, radical simplified is 6 root 2. Okay. Now there's going to be a pattern that emerges. So I want you to take a second. Think about this question that we just went over. And then if you figure out the pattern, I want you to go ahead and do A, B, C, D, E, and F. It'll take you probably 30 seconds. If you didn't figure out the pattern or if you don't understand, please come see me. So take a minute to look at that. Now, if you looked at that, you would discover what this is saying down here about 45, 90 degree triangles. So a 45, 90 degree triangle is a special right triangle because if the sides are going to end up being the same, and then the hypotenuse is just the side times root 2. So that's the trick. That's why it's special. Okay. Now we're gonna move on to the next page. Oh, I did not hit. Okay. Now we're gonna look at some examples. So, example one is asking us to find the value of x. Okay. So if we look at this example, we know that we got a 90 degree, and we got a 45 degree. So that means that this must also be 45. Okay. So that means we're dealing with the 45, 45, 90 special right triangle. Okay. So the rule is, if you're trying to find the hypotenuse, that is just one of the legs times root 2. So one leg is 7, that means the other leg is going to be 7. Okay. And the hypotenuse is just leg times root 2. So that's if you're trying to find the hypotenuse. Okay. Now, if you're trying to find the leg from a given hypotenuse, that's going to be a little different. Okay. So we know that to get from a leg to a hypotenuse, we multiply by radical 2. So to get from a hypotenuse to a leg, we're going to have to divide by radical 2. So I'm going to do number 3, just to show you what I mean. So if we divide 13 by radical 2, okay, we cannot have a radical in the denominator. So we have to do what we call rationalizing the denominator. And all that means is you take the whole fraction and you multiply it by radical 2. So we're going to multiply this by radical 2, and we're going to multiply the numerator by radical 2. Okay? So at the bottom, it's going to cancel out. Radical 2 times radical 2 is just 2. So now at the bottom of the denominator, we just have 2. Okay? And at the top, we're going to have 13 times root 2. Okay? So x, because we have a 45, 45, 90 triangle, x and y are both going to be equal to 13 root 2 over 2. So that's how you work backwards and find find the leg when you're given the hypotenuse. Okay. Now you can go ahead and do questions 1 through 1, 2, 4, and 5. I'm gonna do one of the examples from down here. I'm gonna do A. Okay. Solve for the missing leg of each right triangle below. Okay. Now, if we were to solve using the Pythagorean theorem, right? We know we're looking for a leg, so you know that we're finding either A or B. So we got 4 squared plus x squared equals 8 squared. Okay. Now that's 16 plus x squared equals 64. Take 16 from both sides. We got x squared is 48. Okay. Then we would have to take the square root of 48. So x is just going to be equal to the square root of 48. And again, okay, we have a radical. Always assume we need to simplify the radical. So if we simplify the radical, we're going to get 4 root 3. 16 times 3 is 48, so take that 16, a 4 comes out. So now that we know that, take a second and do problems B and C. I'm going to scroll down to this next part. Move this up here. So now it's asking if we have an equilateral triangle and we add an altitude, cut it in half, what happens? Okay. So as you can see in the diagram, what's going to happen is that we have one right angle, first thing that's easy to see. Okay. Since it was an equilateral triangle, all the angles have to be 60. So in the cut in half one, we're going to have one 60-degree angle. And because the altitude is cutting in half evenly, okay, because it's starting from the vertex, it's an altitude, 90 degree, and it's an equilateral triangle, so you know it's cutting it in half evenly. The angle at the top gets cut in half. So instead of having a 60-degree angle, we have a 30-degree angle. So we also have one 30-degree angle. And the last thing that happens is that the base is only half of what it once was. So our base is cut in half. So that's what happens if you take an equilateral triangle and you add an altitude to it. Now, just like that we did in the other example with cutting a right triangle or making a right triangle from a square, now we're looking at an equilateral triangle cut in half, and they're giving us 8 centimeters for the length of the side. It's asking us, can we solve for the sides of the new triangle? Okay, well, the cool thing about this one is now it's set up in my orientation. So we know the way I normally draw my right triangles, we know that this is going to be hypotenuse, this is going to be the short leg, this is going to be the long leg. Okay. So before we gave it the altitude, this was 8. So that means that the short leg is 4, because we cut it in half. So that's going to be 4. Okay. Now we can use the Pythagorean theorem to solve for the long leg. So we got 4 squared plus b squared equals 8 squared. That's going to be 16 plus b squared equals 64. Minus 16. B squared is going to be equal to 48 again. We got to take the square root. So B is equal to square root 48. If the radical can be simplified, we always have to simplify it. Okay. So the square root of 48 simplified is going to be, again, we saw on the last page, 4 root 3. 16 times 3 is 48. We pulled out the 16. So that's how we got 4 root 3 there. So if you're given this situation, and you're given one side, okay, you can find the other sides based on knowing one side and the angles. And this is a special triangle. We're going to call it the 30, 60, 90 triangle, as you see down there. Okay. So I want you to go through, do A, B, and C. You can look at the theorem for 30, 60, 90 triangle if that helps you to figure it out. But now I want you to go and do A, B, and C and see what you get. Should be a pattern for this one as well. So I'm gonna go ahead and go through these because you're gonna do the ones at the bottom anyways. So I'm gonna move this down here. Okay. So if we know that one of the legs, so it was an equilateral triangle. Okay. I'm gonna draw the first one out. All the sides were 4. We added an altitude. Okay. Now, based on where the right angle is, we know that the hypotenuse, or C, is going to be 4. Okay. We know that the short leg at the bottom, because it got cut in half, is just 2. So the only other thing we need to do is solve for the long leg. So we can set up our Pythagorean theorem. And we would get 2 squared 4 plus b squared equals 16. B squared equals 12. Now if we take the square root, b is going to be the square root of 12, but then we can simplify that radical. So it's actually going to be 2 root 3. So b is equal to 2 root 3. So hopefully you're starting to see the pattern. For b, it's going to be the same thing. The hypotenuse is going to be 10. The short leg is going to be 5, half of that. And the other leg, the long leg, is going to be the short leg times root 3. So b is going to be equal to 5 root 3. Same thing for c. Hypotenuse is 12. The short leg is going to be half of that. And then the long leg, or b, is going to be short leg times root 3. So with that information, that's for a 30, 60, 90 triangle. Okay? That's the thing. That's what makes it special. So when you cut an equilateral triangle, I'm going to go back to the one I drew. We got a 90-degree angle. Because it was equilateral, this angle is 60. And the 60-degree angle at the top got cut in half, so it's 30. So that's another special triangle, the 30, 60, 90 triangle. So to conclude, our 2 special cases are 45, 45, 90 triangle. It has its own rules. 30, 60, 90 triangle has its own rules. Now use those rules. They're going to give you a combination of sides and angles at the bottom of this page. So use those rules to go ahead and do the questions at the bottom of this page. If you need help, please ask me. When you finish, have me check it so you can get your homework. And this one was a short one today. That's all we have. Let me find the recorder. All right, until next time.